Hello, good morning, everybody. My name is Rina. Welcome to my YouTube channel. So, we're going to continue with our playlist on statistics, and today we're going to see something called as measures of dispersion. So, measure of dispersion. Here we'll understand dispersion. So, what is dispersion? It gives you a clue of how spread the data is. How dispersed the data is. So we're going to take a look at it. In a measure of dispersion, we have variance and standard deviation. We're going to see how these are important. So let us take, for instance, you have a data set. You have a data set. Say data 1. Data 1 is equal to, we have figures in it such as 1, 1, 2, 2, 4. Let's see, I'm taking the same example from my notes so that it's easier for me to explain. So you have this data set 1, 1, 2, 2, 4. You want to calculate the mean of this data set. So the mean here, when you calculate the mean, the mu, the mu. So let's see, 1 plus 1 plus 2 plus 2 plus 4 is 10, right? 10. 2, 2, 6, 10. Divided by 5, which is 2. So here, for this data 1, the mu is 2. You have the mean 2, okay? Now let us take an example of a data set, the second data set. Let's see. Let's say our second data set, you have different values such as 2, 2, 2, 2, and 2. Okay, you have 5 2's, which here also makes a total of 10, and for a mean divided by 5, you get 2, right? So here also the mean is 2. Good. Now, if you want to know, you get a mean, you want to know how come that these two data sets, they have the same mean, but they are different. How can you prove that these two data sets with the same value for the mean has different data sets? They have different figures. How can you prove that? So here is where variance comes into play. This is the importance of variance, where you can prove that even though two data sets have the same mean, but they are different. They're completely different data sets. Okay? So variance it proves that data 1 and data 2 are completely different data sets. Okay, and now for the formulae, variance, we have two types of variance. You have first, maybe you saw that at high school, you have the population variance. Okay, population variance. And the sample variance. Okay, sample variance. So let us take a look at the population variance. So variance is denoted as symbol sigma square. Okay, this you have to remember, sigma square. This is the symbol for variance. Sigma square is equal to summation I is equal to 1 to capital N, because the population population variance is represented by population sample is represented by capital N. Okay, we saw that earlier. So summation I is equal to 1 to capital N xi minus mu, population mean is mu, don't forget, square divided by capital N. Okay, this is the population variance formula. For the sample variance, it's a little different. Sample variance is denoted by letter S square. Summation I is equal to 1 to small n, because the sample it's denoted as small n. Okay, bracket xi minus x bar. This is important. X bar is the symbol for sample mean. Square divided by n minus 1. This is different. N minus 1. We are going to see later why we have to put this n minus 1. There's a reason for this. There have been many mathematicians, many researchers who created this formula for sample variance because of some reasons, and they have come up with n minus 1. And we're going to do a special video for showing you why this n minus 1 was inserted in the sample variance formula. Okay, so this is for variance. Then we have, of course, the standard deviation, which I think you're familiar with. So formula of standard deviation. Standard deviation. Standard deviation is represented by sigma, okay? Because it is the square root of variance, okay? And square root of sigma square is sigma. Square root of variance. So here it is. Variance and standard deviation, which are two important aspects of measure of dispersion. I hope you understood. I hope you liked the video. Thank you for watching. Please like and subscribe to the channel for more information. Bye bye.